All right, hello. I wanted to kind of pick up from where we left off in class last week and just kind of finish this and provide it to you so that I didn't feel like I had completely left it off. So we were looking at the idea of determinants. And so, the determinant is of a matrix, and a matrix in math is just the name for like this rectangular arrangement of data. Usually it's numbers, and they're usually square, but not always. Square means they have the same number of rows as columns. So this is 2 rows, 2 columns. Um, this notation for determinant is pretty common, but the MyLabs Plus just uses kind of like absolute value bars around it. And this is the standard like definition calculation for a 2 by 2 square matrix. And it kind of looks like, again, cross multiplication. And so just making up 4 numbers, this determinant would be 2 times 1 minus -5 times 3, which would be 2 minus -15, which would be 2 plus 15. And so this determinant is 17. And so I think we did one together, maybe two. And I said, we'll kind of pick up from there. It's called a determinant because what does it determine? And so it can be used to determine the system of equations solution if you convert thinking of the solution into a matrix form. And there's a chance you saw this in Algebra 2, but I won't say that it's a great one. So let's say we were trying to solve that system. We could use normal methods that you do recall from Algebra 2, but you're supposed to see this method in this class. So the first thing we're going to do is talk about how you turn this into a matrix equation. So for a matrix equation, there's a coefficient matrix times a variable matrix and that's equal to, I usually use the word result matrix here. And so it's going to take all this information and it's just going to rewrite it in a new form. The X and the Y are in the variable matrix written in a single column. The answers from up here are what I call the results. And they're still written in a column. And then the coefficients from this system become the numbers in the coefficient matrix. And fortunately, it works about the way you would hopefully guess. You just kind of copy them down. And so this is the same information. And you see it this way in Algebra 1, Algebra 2. And there's a chance that maybe you saw this in Algebra 2, but I'm not going to count on it. So this is more of like a college algebra kind of way of looking at this. And from there, you can use matrix methods to solve the system in a lot of different ways. But I only have to teach you one way in this class, and that's the method of determinants. So I'm going to call this capital C for coefficient. And I'm going to find the determinant of matrix C, which would be 2 times -2 minus 5 times 3, which would be -4 minus 15 would be -19. And I'm just going to hold on to that number for a minute. I'm going to form a new matrix. And what I like to use as the notation is C subscript X. So I'm going to take this coefficient matrix and I'm going to replace the X coefficients from this column with the numbers from the result matrix. So those two numbers are the 11 and -1 from the result matrix. This column is still going to be the same thing for Y as it already was. And I'm going to find the determinant of that matrix. Which is going to be -22 minus -3, which that becomes a plus, and -22 plus 3 is -19. It's kind of coincidence, and you'll see why in a minute that this is the same number as that number. Likewise, I'm going to define a new matrix CY, and for CY, I'm going to leave these X column coefficients alone, but I'm going to change the Y column coefficients to the results 11, -1. The 2 and the 5 stay the same. I'll find the determinant of CY, and it would be 2 times -1 minus 5 times 11, which would be -2 minus 55, which would be -57. So we got a very different number that time. And then it turns out that these numbers will actually let us find the values of X and Y. It turns out that X is going to be equal to the determinant of C subscript X divided by the determinant of C. C subscript X determinant was -19. The original determinant is going to go in the denominator was also -19. And -19 divided by -19 is +1. Y, similarly, would be the determinant of CY divided by the original determinant C. So -57 is the numerator, -19 is the denominator, and that happens to be 3. And so if we go back to the original problem and ask ourselves, does X being 1 and Y being 3 work well and make both of these equations true? And if you check both, 2 times 1 is 2, 3 times 3 is 9, 2 plus 9 is 11. 5 times 1 is 5, 2 times 3 is 6, 5 minus 6 is -1. These actually do work, they are the solution. And so it's a way to solve systems that lets you take some of the guesswork, so to speak, of maybe how to go about solving it out of the question. You can just always follow this procedure. And so it actually kind of works well for computers because computers can do a lot of this math very straightforward, and it's always the same no matter what the problems look like. It can be extended to larger and more complicated systems. Now, we're not going to do that in here, but they at least kind of hint at the fact that that can happen because they do ask you to find determinants of 3x3 systems, of 3x3 matrices, which would be the start of looking at how to solve systems of equations that are 3 equations with 3 variables each. So there would be X, Y, and Z using determinant methods to solve the system. But all you have to do is be able to find the determinant of a 3x3 matrix. So you won't need this first part for the homework, but I just want to kind of show you a 3x3 system would have 3 equations. Each equation would have 3 variables. I'm just making numbers up because I'm not going to actually work like the full problem. Let's say you even didn't have a y in this equation. So that's got three equations, three variables, x, y, and z. And so the start of things that you wouldn't have to do in this class, but if you keep taking more classes, maybe you have to do is you would end up maybe learning how to solve this using determinants. All they want you to be able to do in this class is do the determinant part. So let's think about the coefficient matrix. For a 3x3 here would be the 2, the 5, the -1, the 3, the -1, the 2. That has an understood coefficient of 1 because y is missing. This coefficient is 0. That coefficient's 1. All they expect you to do is be able to find this determinant. To find the determinant of a 3x3 matrix, there's more than one way to do it, but the way that MyLabs Plus offers as a hint is to copy the first two columns and then you do what's called a lattice method. And this only works for 3x3 determinants. And it makes it work similar to the 2x2 determinant. So you start in this corner at the 2, and you go diagonally across. And you're going to multiply all those numbers together. And you're going to multiply all these numbers together, 5, 2, and 1. And you're going to multiply all three of those numbers together, -1, 3, and 0. And part of the idea is that similar to with the 2x2 matrix, this was a positive diagonal, so to speak. So all three of those are positive diagonals. So those are plus signs between those multiplications. Now, here, there was also this upwards diagonal, so to speak, and we did a subtraction by that. So on the 3x3 matrix, sorry, I was looking to see if I had a different color marker handy, and I do not. Oh, assistance from off the camera. That would be an upward diagonal. So minus 1 times -1 times -1. This would be an upward diagonal. So it would be negative or a subtraction. So minus 0 times 2 times 2. This would be an upward diagonal. So we would subtract 1 times 3 times 5. You could also just add all of the up diagonals together as additions, and then just remember to subtract that number from whatever you get for this number. So that's kind of the structure. It's a lot more complicated because there's a lot more pieces. This multiplication works out to -2. This multiplication works out to 10. This multiplication, because there's a 0 in it, would be 0. I'm going to go ahead and write minus and then put the number in parentheses. So this minus is the minus from it being an up diagonal. This multiplication works out to 1. Minus this multiplication works out to 0. So this minus is there, but the multiplication results in the 0. Minus from the fact that it was an up diagonal, but then 1 times 3 times 5 is 15. So then I just need to combine those things. And again, you can kind of cheat here and say, well, I don't care about the zeros. 10's the only positive. The negatives here are -2, -1, -15. That's a total of -18. And 10 minus 18 is -8. And so that would be the start of trying to solve this. But then you would have to, change all these columns one at a time, and you would end up similar to what we did here. You would have, we just did C and got this determinant for the 3x3. You would have to do a CX, a CY, and a CZ, but then you would just do these divisions for that 3x3 matrix. But we're not going to worry about that in this class. In this class, you just have to be able to find the determinant of the 3x3. All right, so thank you, and I hope this helps you finish, maybe not every single question, but at least helps you feel like you can finish trying to look at that most recent homework.